Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture I am going to explain does SN2 means nucleophilic substitution bimolecular, always change absolute configuration. Let's start. This is schematic representation of SN2 reaction. This is leaving nucleophile or leaving group. This is attacking nucleophile or incoming nucleophile. In an SN2 reaction, bond breaking between the leaving nucleophile and the carbon atom and bond making between the carbon atom and incoming nucleophile takes place simultaneously. Means this bond breaking and this bond formation between attacking nucleophile and this R takes place simultaneously. It is having concerted state. This is transition state. So, transition state of single step nucleophilic substitution reaction on sp3 carbon involves two species. One is this substrate Rg and another is incoming nucleophile. That's why this is substitution nucleophilic bimolecular. Now, if you are having here optically active compound or optically active halide with chiral carbon, then what will happen? Here inversion of configuration takes place. Inversion of configuration takes place. Because attacking nucleophile or incoming nucleophile attacks from the opposite side with respect to the leaving group. Now see, this compound is having one chiral carbon because here 4 different groups are there surrounding this carbon. This is your leaving group. Now this bond breaks and this attacking nucleophile attacks from the opposite side with respect to this leaving group. So here what happens? Inversion of configuration takes place. Inversion of configuration means here C2H5 with respect to this attacks takes place from opposite side. So here what you will get? This CH3 and this hydrogen and here Y. This is your attacking nucleophile. So what is happening? Inversion of configuration is taking place. This is attacking from opposite side with respect to X. Now what is absolute configuration? Absolute configurations are RS configuration. It is independent of any reference compound. Now see, this is one optically active halide. This is chiral carbon because surrounding this carbon 4 different groups are there. So this is your optically active halide. If you treat it with Br minus is attacking nucleophile. 2 leaving groups are there, Cl and I. Since I is good leaving group, so this bond breaks and this Br minus will attack from opposite side with respect to this leaving group. So what we will get? Here Cl, here Br, here H, here CH3. Now see, this is Fischer projection formula. This is also Fischer projection formula. Now we have to find out its absolute configuration, whether it is capital R or whether it is capital S. So what you have to do? We know priority is proportional to atomic number of the atom of each group directly attached to the chiral carbon atom. So this is having highest priority. It is having highest atomic number. Next priority is this Cl. Carbon is having third priority and then last priority is having for this hydrogen. You have to check then lowest priority atom or group should be on this vertical line, here or here. Okay, whether it is at the vertical line or not. So here it is at the vertical line. Now, how you have to go from highest priority to lowest priority group. So, this is having highest priority, then this, then this. So, this is anti-clockwise, means it is having S configuration. Similarly, for this compound, highest priority is for this Br because it is having highest atomic number. Then this one. Here in CH3 group, carbon is directly attached to the chiral carbon. So you have to check its priority. So first one is Br, then this one, and this is fourth. Here lowest priority group also it is having at the vertical line. Now you have to check 1, 2, 3 from highest to lowest priority. So it is clockwise, means its configuration is R. So by SN2, what is happening here? Change of configuration is taking place from S to R. Another example we have to see. This is also one optically active halide because here one chiral carbon atom is there. See this carbon atom. Surrounding this carbon atom, 4 different groups are there. So between Br and I, which one is good leaving group? This iodide is good leaving group. So it will go and it attacks from the opposite side with respect to I. So what is there in the product? Here you will get Cl, here Br, here H, here CH3. Now we have to find out its absolute configuration. Now here it is having highest priority, then this, then this. This is fourth one. Now highest priority to lowest priority you have to go. This is anti-clockwise, means its absolute configuration S. What is about this? Here highest priority atom is this one, then this one, then this one, then this one. Priority is proportional to atomic number of each group directly attached to the chiral center. So 1, 2, 3. This is anti-clockwise, means its configuration is also S. Here and here also lowest priority group is on the vertical line. Remember, if lowest priority group is on the vertical line, then when you are going from highest to lowest priority, whatever direction you are getting, that one you have to keep. Means here we are getting anti-clockwise S. Here we are getting anti-clockwise S. Here also lowest priority group is on the vertical line. So here we are getting anti-clockwise, so S. Here we are getting clockwise, so R. So by SN2, here also SN2 reaction is taking place. By SN2, here configuration is changing from S to R, but here we are getting from S to S. So you can conclude absolute configuration may or may not be changed. Absolute configuration depends on the groups and atoms present on the carbon side. This is your conclusion. Hope it's clear to you. If you like, please subscribe. Thank you for watching.